Hello everyone, and thanks. I think the screen goes on and off. I also saw that in a previous talk, so we're going to have to live with that. I want to talk about Makepad Rust applications and AI. First of all, what is Makepad? To give you an idea, it is a high-performance GPU-based UI stack for Rust. It is built from the platform layer all the way up to the user interface. And it has a live loading UI DSL that is not Rust, that is a different language. And it has inline shaders to do the styling. So it doesn't use CSS or vector engine, it uses shaders for everything. Makepad is built out of multiple parts. The main thing is Makepad framework. Okay, if this happens all the time, might be a bit problematic. So Makepad framework is comparable to R, Flutter, or React. You should see it that way. And it is designed for live coding the DSL. So when you have your application running, you can live code the UI styling, so you don't have to restart it. And all of the event handling and all of the code, there is no code in the DSL. It's only style, except for the shaders, which is also style. So the Rust part is where all of the application logic lives. And Makepad Studio, which I'm going to show in a minute as part of this demo, is our IDE. Yeah, the screen, every slide switch is dropping out. It comes back, but I don't know, maybe it doesn't like that the slides are inside of a full screen. Maybe if I make it windowed like this, it will be better. We can try. No full screen, let's give that a go. So Makepad Studio is our IDE. It's in the background here. It contains a code editor, our build system to build different platforms, and it contains our prototype AI generation. Okay, I don't think it mattered if it... okay. All right. It's going to be difficult. Okay. Anyway, so Makepad is cross-platform. It runs on desktop, macOS, Windows, and Linux. It runs on mobile, on iOS, Android, and OpenHarmony, on web via WebAssembly, and it even runs in mixed reality on the Quest. Projects using Makepad are Emotion, it's an LM Studio-like project, Robrix, a matrix client. Kevin is doing a talk about that tomorrow, I think. Makepad Studio, our IDE, is probably one of the most complicated examples of that, together with Robrix. And I have some small videos. I have the demo video of Robrix, a matrix client. This is running inside Makepad framework. So you can see it can draw HTML-like things with links, with rich text, with icons. A pop-up menu, text inputs, all these kinds of components that are needed for a UI framework. Let me see. It also has a dynamic UI with doc. It has all these kinds of responsive UI. When the UI resizes, it becomes a mobile view, and so on and so forth. So we're pretty full-featured in that sense. And finally, also, Makepad runs in mixed reality as well. So here you see a UI with using the intersection of a real-world object with a virtual UI. And because our UI is essentially a game engine, you can even make small mixed reality games with this. This is a test I made on the Quest, ported Makepad to it, and so it goes all the way from these kinds of UIs to mixed reality and web. Hold on. Slides. So yeah. Can we try maybe a different cable or something? Because I think maybe it's the optical. Is there another cable we can use that's maybe less long, or? Okay. So dev tooling is becoming, AI Gen is becoming more and more important for dev tooling. Code is going to be written less by humans and more by AI. And I want to show generating Makepad applications with big cloud LLMs. So big cloud LLMs can generate an application of maybe 1,000 lines in one shot, and they generally work. With the advent of thinking models, it has started to take a long time before the first code gets emitted, because it's thinking, it's planning, it's thinking, planning, and then it generates the app. And it has a high success rate. Most of the time you do this, it will generate a working application. However, it is fragile for larger apps. The bigger the application becomes, the more often it starts to reintroduce bugs or reintroduce things that you already told it to remove. So it doesn't converge very well as you continue iterating on it. So I want to show you the demo app gen for, let's see, I don't think the connector is the problem, maybe, yeah, okay. So, so I want to show an AI application that I created. I tried to make the AI write a little snake game inside Makepad Studio. And because you have so many revisions with AI, I tried to make essentially a snapshot feature, so you can see all the versions of the application that the AI has created. So I'm going to run the application now. Let's see. Okay, here's our first. I'm going to click play on the first snapshot. This is the first version of the snake game that I had the AI generate. It's very basic. It has no styling whatsoever. It's just a plain text or a plain color snake. And then I started telling it to yeah, can we try another cable? Or so I can now click play on the snapshots, and it'll run that version. Here I started to ask it to create a nice background for the snake. It is using the Makepad DSL to style it completely. So the AI knows how to write shaders. It is not that it needed to know CSS. The way Makepad styles its UI with shaders, I don't think I've seen it anywhere else. So the AI is smart enough to do that. It is smart enough to respond to my requests to make it more colorful, add different effects. I think here it starts to, I wanted to make it do a flash when it ate the food. Here we go. But I didn't really like the way it animated it, so then you say, okay, can you make it smoother? And here, at least this one has a smoother animation, and so on and so forth. So here's it, for if you can see it. Yeah, this is a bit dramatic. So here's the animation running with a different style. So you can see that if you work with a large LLM, you can pretty much single shot an application that is of this scale. I also try to have it make a calculator. In this case, it started with essentially a non-working calculator. I didn't see any buttons. Then you go, I don't see any buttons. Could you fix that, please? Okay, now we have a working calculator with buttons. I wanted to have scientific functions in there. I wanted to make the buttons have a gradient. And then I wanted to have a specular when the mouse is over it. As you can see, single shot, it just works. You can talk to the AI to generate this level of application, and that works fine. It does fall off when you have a more complicated application. Okay. Can we use that cable? Okay. Okay, let's see. It's a bit difficult if you're doing a visual presentation and we lose the screen every 2 seconds. Oh. Display. It's not showing in my displays. Choose mirror. Oh wait. Huh? Mirror extend to connected. Choose content. Start mirroring. Okay. Optimize for this one. Then I can change the font size. And I think this is what we had. Okay, hope it's better now, because there's a lot of things to show. So we have here is a calculator. I also try to make something else, because it's more interesting to have different examples. I have, this was a little news feed. I wanted to have it generate. And then you can just ask it to generate different styles, like a white one or a black one or a themed pastel. So you can talk to it about styling and code pretty well. Where's my presentation? I think I can full screen that now again. Here we go. There we go. So that is generating applications with a big language model. With a local model, however, where you use your GPU on your device, things change pretty quickly. You can only really get it to do simple problems. Styling and the shaders is less elaborate, but it does stream in quickly. When you're starting to generate an application, it starts very quickly generating the application, especially if it's not a thinking model. But because it's local, it generally has a speed of maybe like 5 to 10 tokens per second. It takes a long time to generate a whole application. And it also generates many small errors, especially with Rust, like unwraps missing or memory errors. But this LLM could be part of the runtime of the application, right? You can make it part of the system. So when you use AI to generate Rust applications, like Makepad applications, one thing is that it needs to finish the entire application before I can run it, right? And the snake example, it was like 500 lines of Rust, so even if you have a fast cloud model, that takes a long time to build. And it makes still mistakes in Rust code that you then have to fix up, like unwraps that don't need to be there, or the borrow checker doesn't work out for the code. And yeah, so local models are slow, and Rust is verbose. So that means that you spend a lot of tokens on Rust syntax niceties that you might not need. Rust does give useful errors for an agent. So if you have an agentic workflow, it can fix things. However, we've also encountered a lot of times that it doesn't converge. So it fixes it, but in a way that doesn't fix the code for real. So, and if you generate Rust, you of course need the Rust compiler. So you could not ship this to a mobile phone because you don't have the Rust compiler there. So you cannot let AI generate an application if you make the logic run in Rust. And we've also seen a new kind of application, or imagined a new kind of application, where the app is generated on the fly by AI in a conversation context, right? So the application starts to become dynamic based on AI. And that also means if you want to ship that idea inside an application on a device that doesn't contain the Rust compiler, you could not use Rust as the language. And this makes me arrive at the gist of this talk. It's an idea still, and I want to take you on a walk through the concept space here. The Makepad DSL describes the UI styling and the UI structure. And I now propose that we're going to extend that DSL with new functionality. And the new language needs to have a couple of features that I don't think any existing language currently offers. So one of the features, because the AI is generating code relatively slowly, especially if you use a local model, you want to start executing the application whilst it's streaming. So that means we need a language that can work with streaming code and a UI into a virtual machine and start running it immediately. Also, because we need to save tokens, tokens are expensive, they take time to generate and energy, we should design the language to have very few tokens, or as little tokens as we can get away with. And also because we saw errors in the generated Rust with unwraps and all these things, maybe we can design a language that is more error resistant. In a sense, just has less errors, maybe a bit more fuzzy, but yeah. So the language we've named as a working name Splash is essentially the total opposite of Rust. And that's a thought experiment because Rust has a lot of design decisions around memory safety, performance, making sure that every single possible error path is handled in code and that you can, that you could create very stable systems with that. But as we also saw in another talk about the user-friendliness of Rust as a programming language, there are domains where that level of restrictiveness is actually getting in the way of building an application quickly or streaming it from an AI. So I want to go through a thought experiment. What if we make a language that is actually matches Rust, but by being the total opposite of almost every language feature? So we're going to split the domains. So right now in the Rust domain we have things like event handling and building UI. So I'm going to move that out of the Rust domain. Just like a web browser has HTML and JavaScript and CSS to do certain domains, I'm going to move the domain of Rust a little bit back. So the Rust domain will be the OS layer as we have it now, the rendering stack, the interpreter of the new language. And it's going to contain all the high performance stuff, the high performance components and all the things that we need high reliability for, right? We need to have a high reliability code view or a high reliability data grid. We need those widgets to be rock solid. We don't need the AI to generate all of them. We can use them as we've built them in Rust, high performance, stable and reliable. And then the Splash domain is our original DSL domain, which is UI styling and UI structure. But we're going to add to that event handling data structures, so the data the application operates on, the mapping of the data to the UI, and async networking. Async networking is something, and these domains, event handling and data and networking in Rust can be very painful for a UI application developer. So it doesn't only solve that we can generate this way with AI, it also solves that we make application development easier. So I want to go through these differences of Rust versus Splash. So Rust is a very strict language. And with Splash we can go, well, why don't we try to be as easy as possible whilst we can still parse it, right? So for instance, a colon and an equal sign could just mean the same thing in Splash. So when the AI makes a mistake there, it's just ignored. You know, things like semicolons. JavaScript has something called semicolon insertion. And that means that you can usually just forget about the semicolon. You don't have to put it in the language. And the same is here. If the AI makes a mistake there, you can just ignore it. And so on and so forth. You can make the language more resilient to small mistakes. Rust is strongly typed, so as a consequence of that thought experiment, we should try to design a language that has as little types as possible, essentially no types at all, except for values. So Rust is compiled, so this language would only be interpreted, which is exactly what we need for the AI generation and the streaming. Rust has static code. With this, we can do dynamic incremental code. So because the AI is streaming in the generated code, we need a way at runtime to just start executing it as it is streamed in. Rust has very strict error handling. Everything is designed to be rock solid. But with Splash, we could say, okay, why don't we just do our best to try to continue running code, just like a web browser, right? If a web browser, if you click on a button and it generates a JavaScript error, not the whole page crashes. You can just try again, and sometimes that works again. So it can be made more resilient to exceptions, not like Rust when the whole application just crashes or stops working entirely. And we have AI now. So what if, instead of throwing exceptions, we let the AI handle the exception? Because an exception in a program that a user is using is something they cannot do anything about. If the application just stops, the user is left like, okay, well, the application just disappeared. But there's no actionable result there. Whereas if you have the AI online, you can say, hey, exception, AI, could you maybe recover or fix something so that the user doesn't lose its application state or something like that. So that's a new concept that has not existed in computer programming before. That might be interesting to try out. By the way, this is all just an enormous set of ideas that I'm trying to put into this new language. This language has not been implemented yet, but I'm first ideating how this would look. So Rust is long running, right? It's the host of this virtual machine. So it needs to be stable, it needs to not crash, all that kind of stuff. But for a Splash application, it could be ephemeral. It could be just like a little thing that shows up in a chat and only lives for a few minutes and then it goes away again. So does that change anything about how you can design a language when you go from very stable, long running to, well, actually, it's just like a web page. It goes away the moment you click somewhere. So Rust has the borrow checker. I do need to check up on time a little bit. How much time do I have? 5 minutes? 8. Okay. So Rust has a borrow checker. And in Splash, well, we could give it a garbage collector, or we could say something crazy like maybe not manage memory at all. Just let it allocate and free when the application goes away or stops. I'm not saying we're going to do that, but it's these ideas that you can evaluate in this context. So Rust has no inheritance by design. They think it's a bad idea. For UI, inheritance is essential. So Splash will use prototypical inheritance, but it'll use it everywhere, much more than JavaScript. So Rust has no globals. Splash could just have as its state the tree that represents the UI, the tree that represents the data, and global variables. Right? It doesn't live very long. It doesn't need to be refactored. It doesn't need to be modularized and interoperate with lots of people. It just needs to have a very simple representation that the AI can operate on. Rust has limited mutability. We could just say no constraints. Rust has compile time memory layout. We could say, well, we could do query-based data structure access. Every single data structure access is instead a query. And that makes it much more powerful to interact with data and also saves a lot on tokens. So Rust is all powerful. This is completely sandboxed. Rust is as fast as possible, whereas Splash could be maximally designed for expression, for the AI to generate as little code as needed to do what it wants. Rust is verbose. We can design this to be terse. So yeah, wait a minute. It looks a lot like JavaScript, right? The original JavaScript, not the TypeScript direction that we know now today. JavaScript is weakly typed. Everything is an object. The browser is error resilient. But as web applications grew, we realized that we needed to build more and more and more in JavaScript. And in a browser, the C++ code is not accessible to an application developer. It is fixed. You can never change it. It changes, maybe every decade or so. So you cannot use it in your application design. And that means that JavaScript had to become like C++, like Rust. It had to incorporate types, because otherwise we couldn't build applications big enough. But that problem we don't have with Makepad. We can do things in Rust that need to be done in Rust, and then you can make the other side actually make JavaScript go in the different direction than TypeScript. So you can make it more dynamic. And for that, I wanted to fix the JavaScript syntax, because I've been doing a lot of JavaScript work before I did Rust, and there are some fundamental problems with JavaScript that you can now fix in this concept. So for instance, prototypical inheritance in JavaScript is shallow. So if you have a.b.c, and b is an object on the prototype of a, if you mutate that, the value on the prototype gets changed, which is absolutely unexpected. You want that to be copy on write deep. And also object and array constructors are not normal code. You cannot write a for loop in an object constructor, and that is very limiting if you're describing dynamic UI. And of course, there's common failure modes, like if you have a.b.c and b is or a is null, then the whole chain fails, right? This is why we have the dot question mark, so that these chains don't fail. We can fix that so that the code becomes less brittle when, for instance, the input JSON doesn't match. So more dynamic, not less. So what can it look like? I want to quickly show what this could look like for an application. I think we're also reaching the end of our time. So this is the syntax of a to-do list application. As simple as I could write it down. It doesn't have any UI styling, it just has the UI components. And here you say to-do is an object with just a bool, done. And then you say to-dos is these things. So this is inheritance in this language. So this is prototypical inheritance. JavaScript makes it very difficult to do prototypical inheritance dynamically. I want to do it everywhere. This is the same for the UI. So here you have a prototypical inheritance of a UI component, and then you can specialize it by providing, for instance, callbacks or other methods. These are all the UI components that we have in Makepad. So we're just using direct Rust UI components, and this language is deserialized into the Rust side. So this is how it works now in the DSL. I'm going to do it the same way. And here you draw an item. So this is a to-do item. Here's the text input, the checkbox if it's done, and a delete button next to it. And you can then also experiment with things like data binding syntax. Like in Rust, this is now a lot of code, but in this language, you can just say, hey, just bind this value directly to this data element, right? And when this data element gets changed or deleted, we can add observability to the data structures. All of these things can go into the language VM. And if you look at this code, you have to imagine that the AI is generating it like this, right? It's generating it like this. So we already have the to-dos, and the code is right here, and it generates the text input. The UI could already show the text input, and as this is generated, the UI populates with the other UI components as it is generated. And then we have an add button and a clear completed. This is a nice example of how you can write query-based data structure access. This is actually JSON query. But if you put that into the main syntax, you can say, hey, delete all the to-dos that are done. And in this case, you probably don't even need to do the is this true, because a Boolean is already enough for a query like that. And as you can see, this is very token optimized. It's not a for loop, it's not a piece of functional code. It is a query, just like how you would query a database. Another thing that you can do when you're designing a language like this is you can say, hey, I'm going to run a worker with this code and then download my to-do list from a server. And then what I do is, as the items download, I emit code to the main thread. I don't send it a message. I just run this piece of code on the main thread. And this data can just be deserialized into the generated code. So it's not sending over a message. It's actually sending over code that is interpreted on the main thread. It's just a thought experiment, like, hey, what can you do if everything is interpreted and can be extended at runtime? Well, you could do stuff like that. And here you can see, for instance, if you have a long to-do item, so you have your whole UI populated, it's generating a to-do item, and this text is very long, you can just see it update in the UI as it is generated, because that is the way it is designed. Okay. Let's see. So, yeah, now I'm going to implement this. I think I've ideated it well enough to now be able to start implementing the interpreter for it. I have all sorts of ideas of how to implement it with NaN code encoding. So essentially the way a JavaScript virtual machine encodes its values is using NaN boxing on a float. So that means that you have a certain bit space in a floating point number. Okay. Anyway, I'm not going to go into that. But yeah, there's lots of interesting new areas that we can explore with this. So thank you. This is the repository. You can run the examples, you can run the application, our website. Any questions?
我们可以提一个问题 ，OK？
Hey, thank you for the talk. I'm just wondering, how do you handle the layout when you generate the code? So do you have, like, have you considered something like drawing on something like a mock-up, then just giving that to AI with whatever logic that you want to have, and then generates the whole thing?
You can do that. I haven't really ideated that part yet. It's mostly, the idea is that this is not an application developer tool per se. This is a way for the AI to generate UIs for you in the flow of communicating with you. So it is unlikely that you will specify things to that level because the mode of this system is that the AI should already know what it would look like. You can of course do that. I haven't really nailed down what the domain of this language is. I think it's also going to be great for humans to write applications with, and I think it's going to be great to make Makepad accessible to a larger audience than having to write everything in Rust. So this use case where you describe a layout will most likely also just work. But yeah, I haven't really figured out what the mode of interaction with the AI is going to be in this regard.
Got it. Thank you.
Thank you. Thank you, Rik.
All right. Thanks, everyone.